Hello, this is a video on the overview of concentration. Concentration is the concept of how much solute or solvent is in a solution. So basically it's the recipe to make the solution. Now, before we discuss the different types, let me just give you a quick overview of big picture things that should have already have understood, and then we'll get into actual concentration information. You should have already made a copy of this and have some notes, someplace to take some notes. To have a concentration, you must have a solution. To have a solution is a homogeneous mixture. It's not a heterogeneous mixture, or what I call two phases. How do you know when you have a solute and a solvent, they actually come together to form a solution? The phrase is like dissolves like, and we have talked about this before. So your solute and solvent have to be a certain type for you to have a solution. The other big thing about solutions is, well, the solvent doesn't disappear. What's happening is, the solute does not disappear. What's happening is the solvent particles are separating the solute particles so that they are basically surrounded by solvent particles. So the solute particle doesn't disappear, they just separate. So therefore they need to be they're going to occupy the space between the solvent particles. So therefore, one of the big things you need to understand is if you simply have the solvent, there is empty spaces between their particles being base units. So in a bucket of water, there is empty space between the water molecules. And now that empty space will be where the solute base particles, base units, whatever you want to call them, will reside. And that's true for anything that dissolves. The word also is miscible. Miscible is when two liquids dissolve. So therefore, if you're simply just taking solute and allowing it to dissolve into the solvent, there's only three things that can happen. So if you start off with a bucket of water, let's say, as a solvent, suppose solvent, and add in salt, which is an ionic solute, they will dissolve in each other because like dissolves like, and they both have Coulombic force to them. So once you put in some of the salt in, the salt will dissolve into the ions, and the ions will go into the empty spaces between the water molecules. That is called an unsaturated solution because not all the empty space has been taken up by the base unit or particles of the solute. There comes a time, and you keep on adding, let's say, solute into it, there comes a time when you can't put any more in. That's called the saturation point. The solution is said to be saturated, and that is equilibrium. It's solid equilibrium. So it's an equilibrium between the solid, in this case solid solute, and the ion form of the ionic compound. There is no empty space left. And then if you keep on adding in solute after that, what happens is you simply accumulate the solute, the added solute, in the bottom of the bucket, or the floating on the top, because you can't add any more solute base particles in between the solvent's base particles because there's no more empty space. So what you get is a saturated solution with the solute either on the bottom or the top, depending on its density, and you have not added in any more, dissolved any more solute. Okay? Now, concentrations are separated because there's a number of different ways of telling somebody how much solute you need to be put in a given amount of solvent to be given a certain amount of solution. And they're basically broken up into what kind of solutions that they can have. The key is solubility. Okay, solubility, which is a type of concentration, can only exist for solutions that are at the saturation point. All the other ways of saying concentration, molarity, molality, mole fraction, mole percent, mass percent, volume percent, they can be for any types of solutions, either saturated or unsaturated. Remember, there's no such thing. There's nothing else besides saturated and unsaturated. Okay, as long as you don't change as long as you just add in solute into solvent. So therefore, only solubility is at the saturation point. Everybody else, you can find the molarity or molality, let's say, of any solution. And molarity and molality are the most common ones that we'll use, and solubility. The other ones I just gave you kind of as a reference because you can, but you don't have to actually. A lot of times people don't use mole fraction, mole percent, mass and volume percent. But sometimes they do. For example, isopropyl alcohol, if you look on the cover, it says 70% V/V. That means 70% of that solution is isopropyl alcohol, 30% is water, and it's both by volume amount. Okay, so now what you're gonna do is you're going to have a different video explaining you solubility, how to calculate it, what it is, molarity, how to calculate it and what it is, and molality, how to calculate it and what it is. And then the other ones I most likely won't do a video on. Okay, I hope this helped.